learn Python programming language, what you will be able to do, you can automate the systems, you can build the applications, you can analyze the data, you have control over the hardware, and you can manage the complex scientific workloads or any information. So here you can understand Python has a scope in all the areas. So once you learn the Python, you can go ahead and choose one of your relevant. So let's move on to the next slide. System programming and automation. That is the first point. So Python can interact directly with the operating system. That means it can handle the work with files and folders, read and write environment variables, launch other programs, manage processes and threads, and process and perform parallel tasks. So first point means generally you interact with the files and folders when you write programs. So it's a basic thing in the programming world that you usually interact with the files and folders. Even you write the environment, you can read and write the environment variables. Environment variables are like a configuration which are written in the system so that you can operate, launch other programs. So let's say if you are running your application and you want to start the Chrome browser or any different application that you want, so you can trigger that event in Python program itself. Manage process and threads. So manage process and threads means you can, if you go and check task manager in our operating system, you will see multiple tasks are going, and we have many applications running simultaneously. So these are the processes and its threads. So here, so what you can do, so you can do manage process and threads similar way as a task manager in the Windows operating system. Perform parallel tasks. So you can perform the parallel tasks, you can run multiple applications parallelly like server client, and you can interact between that client and build one application. So there are many applications and scenarios for this. A Python script written for one operating system usually works on the others with a little or no change. That means once you write the program, Python program, that means in day-to-day life you see all the applications which has a user interface. So if we don't have user interface, user will not be able to access it or use it properly with a user friendly manner. So generally all the applications have user friendly layouts for your mobile desktops in the form of mobile applications and Windows applications. So its design allows developer to create windows, buttons, forms, and dialogues quickly. So Python has a framework where you can use the libraries and frameworks which can build UI applications using its libraries. So these applications can run across multiple platforms. As I said, it once you build the program, you can move it to any operating system with smooth. You can take it to any operating system smoothly. This makes Python strong option. So internal business tools, enterprise web application softwares, and utilities and configuration panels. So these are the three applications or three areas where user interface is required most of the time for the users. So you can start building these applications if you are looking to build an application using Python. So you start building these small applications. You start building these small applications and you will get the hands-on experience, and then you can understand the importance of Python in GUI. The simplicity of Python reduces development time, which is why it's known for speed and maintainability. So it has a larger community, so it is a well maintained, and it is continuously evolving programming language, and Python reduces the development time, so you can build the applications in a shorter time. Let's move on to the next slide. Internet and network programming. So here also Python plays an important role in the internet and network programming. So Python is a commonly used behind the scenes in the web application to process the request, handle data, and communicate with other services. Just like in web application, you can build any application using frameworks like Django, which are built in the Python itself, and you can build a quick web applications using those frameworks. Those are specially known for quick application development. With Python, programs can communicate over the network. So HTTP request, any other port request you can do, act as a client server, client or server, transfer data between the systems. Python can work alongside code written in other languages such as C, C++. So there is no bounding that Python will work only with the Python program. It has a liberty to, or it gives liberty to you to interact with other programming language as well. This allows developers to control existing system using Python scripts. So you can write a Python scripts like generally we use in AWS, Lambda. Those are Python scripts that we use to interact with the existing systems. So you can start focusing on this one. Extend Python with high performance components. So if any system is taking time or having performance issues, so you can just take it out and write it down in the Python and link it with your application, something like that you can do as we do in the AWS cloud systems. So there we will achieve the high performance of that program or that application. Embedded Python into a larger application. So generally in embedded systems you can use Python, which are used in the cars and machines, where it can interact with the machines and give, or it can interact with the machines directly based on the program. So you can write the embedded systems as well. So in practical terms, this means Python is often used as the top level orchestration layer, coordinating complex systems while relying on the lower level components for performance critical tasks. So what do you mean by this? So generally when your component integration is there, you generally focus on the single part or any specific part that you want to move from the base application, build it in a Python and link it with the your application. So it will interact with the application with the high performance. It can handle the complex task and it will resolve the performance issue, maintainability issue. So that is possible. So let's move on to the next slide. So for the database programming, Python is widely used in database driven applications. It supports integration with almost every major database systems and provides a consistent programming interface for working with the structured data. So as you see, we have structured and unstructured data. Like in structured data, we can say SQL Server, MySQL, Postgre. These are the structured databases, and we have some unstructured data like audio files, video files, and JSON format. So these kind of unstructured data is there. So for with both the data types or databases, Python is compatible, and you can use it along with the Python. So what Python can do for developers can query update databases. Query update means it can perform the CRUD operations basically on the database, stores application data, persist objects between sessions, and switch database backends with minimal code changes. So this is the biggest point that you can see in the Python. You can switch to any database with very minimum changes. So this is the one of the important point for the Python. So rapid prototyping. What is rapid prototyping? Python is concise and expressive. Developers can quickly test the ideas, build working models, and refine solutions. Means, let's say if you have a idea about any project, so you can start implementing it with the small project using frameworks, Python frameworks. So it will give you a liberty that it will be in a smaller time. You can build these prototype applications in shorter time of. So let's say if you have any idea and you want to build an application, but you want to test it before you want to go ahead and build it in a or convert it in a large application. So here you got the idea. So you tested it using Python frameworks, and once you confirm how it works, then you can move it to the larger applications simultaneously, or step by step you can convert it into the large scale applications. What makes Python unique here is that prototypes don't have to be thrown away. Part of the system that performs well can remain in Python, while performance critical components can be written later, so without redesigning the entire application. So what does it mean? Like once you start the building application, you can start with the small applications and eventually you can convert it into the large application step by step by adding complex and critical components as you go. as your user increases or the application level, you can upgrade the application by adding complex critical components later. So understand this, part of the system that performs well can remain in Python, while performance critical components can be written later without redesigning the entire application. That means your idea is converted into the smaller application, and now you want to add some complex critical components in your application. Then you can just go ahead and add it and scale up your application to the next level without changing the prototype or any major changes, without doing any major changes in the application. Let's move on to the next slide. Numeric and scientific computing. So here Python plays. Uh, so here Python is also heavily used in the numeric and scientific computing. It supports advanced mathematical operations, simulations, and data processing by combining easy to write Python code with the optimization numeric engines. What does that mean? Means you can build large data set, or you can handle large data sets through Python. Complex calculations, you can do complex calculations, scientific simulations, and visualization and analysis. So here you can see in the modern days, nowadays Python is widely used in the models as well, AI as well. So here you can see the advantage of Python in as a data science. You can use it as a data science for scientific reasons to analyze big data, complex things you can do here. Let's move on to the next slide. So this is one of the interesting part where you can build programs like games, media, robotics, and AI. Python's flexibility allows it to be used in the many specialized domains. It applies to game development and media, image processing and video processing, hardware and robotic control, artificial intelligence and machine learning, natural language processing. So all the major aspects of future related career or future related applications you can build in Python itself. So this is how Python becomes a most important language that you should learn or should have something that you can build as a basic programmer in Python. So it will be create, or it will create an impact on your profile, that you know the basics of Python and you can adopt it whenever required in your corporate working environment. So this is how Python becomes important. So these are the various areas that Python is important and widely used, and this is how the Python becomes more and more interesting and important language to learn in nowadays, by understanding the future of the tech world and the technology that is continuously evolving and growing. So you can start with the Python. Thank you.